So hi, I'm Colin Rice. I'm working on Skeleton. There we go. So I'm just going to explain what it is and sort of its use case. So what is Skeleton? I lied. First I'm going to talk about how the RCOS website is deployed. Because I don't think anyone in this room knows how it works. So that means if I get shot, you're all in trouble. And it's a giant mess that I want to talk about. So there's sort of four components to the RCOS website. This is rcos.rpi.edu. There's a database. It stores all your information. It's a SQL database, PostgreSQL version 9.2. That's pretty much all it does. There's some screenshot file storage. So when you upload an image to RCOS, it actually just gets dumped in some folder, sort of buried deep in var www. And I feel like there's a security hole there, but I haven't found it yet. So if you find it, don't destroy the server, pretty please. There's a sort of a Django Python-based renderer that takes in your request and whether or not you're logged in some cookies and stuff and produces a bunch of HTML. And then there's an Nginx web server that's really being used as a load balancer because it multitasks your incoming requests between 4 Python instances, and it also serves static files. So like your web browser, you pull up the RCOS homepage, it loads that logo in the top left corner. Nginx handles that rather than making the Python handle it, so it's much faster and makes our logs a lot less cluttered. And so this all seems simple-ish, right? Is anyone here vastly confused by this? You are? Anything I can help with, or is it just... Okay. And so how do we set all this mess up? If I can't help, plus I gotta go quick, there's a guy actually who needs to go. So originally this was all deployed because someone SSH into a machine and set this up by hand, and it's a pain in the butt. And it was very unique how they set it up, and no one knew how to update it. And so over time, the setup sort of evolved into a giant nightmare that no one could understand how it ever came into existence, but everyone agreed was bad. And so I redid it. It uses a system called Puppet, which essentially is a way to describe the state of a machine using a programming language. And like that ugly Puppet, it works, but it's ugly. To actually deploy, we use Puppet glued together with some bash scripts I wrote, and this thing called South for database management. I'm not going to get into because that's a whole other lecture. And it works, but there's a lot of problems. It's really slow, mainly because Puppet does essentially file comparison, and our disk drive in the server in the basement of Amos Eaton is completely horrible. It's from like the 90s. Comparing 4 meg files takes like 5 hours or something. So it takes like 20 minutes to do a deploy. How many people in this room know Puppet? So there's like 4, maybe 5 people in this room who could write a Puppet config potentially to update the server. Also, because of how the Puppet deploy works, it sort of leaves breadcrumbs behind. Because it's attempting to deploy a changing target, and for speed reasons, we don't wipe the machine completely clean and redeploy. And so there's remnants left behind from when I wasn't smart enough, or it's just hard to do. There's this really bizarre integration with Git. There's no way to roll it back. So if I do a deploy that really sucks and takes out rcos.rpi.edu, I can't just be like, undo that. I have to actually go in and figure out what the difference I made was and like deploy back to an earlier state. It takes more thought than it should. And you can figure out our PostgreSQL database password by looking on the Git URL because we don't handle our secrets properly at all. Don't worry, you can't access it remotely. And it's only SSH key logging, so it's not as bad as it sounds. So that's a giant mess. And there's this exciting new thing in the world of deploying software called Docker. Its logo is a whale with some shipping containers. And so basically, how this works is, it sort of looks at the standard picture of deployment and it says, we hate this whole nightmare, and it goes in its own little direction. So how many people here have used Amazon Web Services? Right? And so in Amazon Web Services, you make these machines, and they're actual virtual images, and they run in virtualization software somewhere in an Amazon data center, perhaps with armed guards. And that's how you deploy in Amazon. And so with Document, their idea was like, look, all you really need to know when you're deploying is what the file system should look like and what the binary is, and we can just wrap this all up. And so, I'm just going to jump to the next slide. So when you make a Docker deployment, you just do something like this. So you go, I'm deploying something that runs on Ubuntu. So from Ubuntu, I mess with its app sources a little bit so that I can do some updates. I install these 2 programs, I make a directory, I run a couple commands. This is the port you talk to this on, and this is a version of Firefox that you can SSH into via X and browse the internet from. It's like 6 lines, it's pretty trivial to deploy, it uses like 10 megabytes of RAM. That's pretty much it. Under the hood, it takes advantage of this thing called Linux user namespaces, which is essentially a way to run a process and hide the fact that it's not the only process on the system, which is very cool and interesting, and we don't have time for it. Right? But this is a very easy way to describe software, because you just go, oh, I install it here, I make these changes, run it with this command, this is the port it opens, we're done. But the question is, how do you deploy this, right? And so no one's actually made a system for deploying Docker software. They never actually realized that people might try and use their software to deploy it over a couple hundred machines. So there's all sorts of interesting bugs. I actually have to write some code for them. But basically, everyone was just using it on their local machine. They were making Docker containers on their local machine. They were running them on their local machine. They were going, this is really cool. Let's go write some patches for it. So Skeleton's designed to fix this. So essentially what Skeleton is, it's a bootstrap utility. So you've got a bunch of Docker files that represent Docker machines. Perhaps you just have Docker machines that are stored in some registry somewhere. And you want to deploy them on 10 servers, 100 servers, whatever. And so you tell Skeleton, hey, I want to deploy these. And Skeleton goes, okay. And so the actual Skeleton binary brings up this thing called the orchestrator. And this is a Docker machine, just like everything else. And it looks at all the Docker machines it knows about, and it figures out what's running, figures out what's not, it figures out what changes it has to apply. There's one other sort of major component, and that's a secret manager, which handles like database password keys, stuff like that. I'll talk about it more once I've written it. Right? So, I'm just going to skip this slide. So I'm just going to go straight to the demo. So this is what Docker actually does right now. So this describes the deployment. Nominally, this describes the RCOS setup, right? So there's 4 machines. I'd love to pretend we have 4 machines. And those are their IP addresses. And how you get to them is I just hard-coded them, so you can just SSH into these things. In the future, I want to be able to say, like, these are on Linode, and if they don't exist, bring them up and stuff like that. But for now, they're all hard-coded. You tell the containers you want to run. In this case, there's a Django container, there's a PostgreSQL database, there's a file server. And that's it. Anyone have any questions about this file format? It seems pretty simple to everyone. It says what it needs. I'm doing it in JSON because everything can parse it. I'm sure at some point I'll write a prettier interface once looking at what exists for Go. So if you run this, right now, this is the output you get. So this is loading the bone file, and oh shoot, this might take like 5 minutes. This is loading the bones file and actually deploying it onto a virtual machine that I have running on my laptop. And so what I did is looked at the bones file, it figured it out. It was looking for an orchestrator, because you might deploy to something you've already deployed to. It didn't find anyone, so it said, okay, I need to bootstrap the orchestrator. So it told the Docker instance it talked to that decided it should host the orchestrator instance to build the orchestrator and deploy it. And so what you're seeing now is the build output. So it pulled the base image that the Ubuntu image is based off of. It is now 13% downloaded. Hopefully this will get to 90% before I run out of things to say. So basically it pulls the whole image, and then it sets up the orchestrator, and then it just tells the orchestrator to display everything else. And that's how much code I've written so far. That's pretty much it. I'm just going to stop the demo now, because it's not much more interesting than this. But that's really Skeleton in a nutshell. So obviously, I need help. I know everyone's been saying they need help, but I really need help. This is desperate. I'm building the future of deployments. And it's sort of a cool thing, because there's a lot of deployment software out there. I can name like 5 names off the top of my head. And they all sort of do the same thing. It's the next slide, Brock. I got this. And they all do the same thing, right? And no one's really rethought deployments. And so, rather than just letting you deploy Docker images, I'm letting you deploy Docker images, and I'm also handling all your password secrets for you, because everyone messes that up. And even if the credit card industry requires you to keep your secrets properly, everyone still messes it up, which is why we all lose our credit card numbers once every 2 years, right? And I'm also adding some standard database images, because like a lot of systems, like Puppet is a classic example. Great way to describe machine state. There's literally 400 Puppet files out there, or Puppet modules, to describe how to deploy a PostgreSQL database. Because every single person wrote their own because they didn't like how someone else did it, and there was no standard way to merge them all together into one. Because they're all doing the same thing. So I hope to do a little bit better this time. There's a lot of stuff to do. I'm just going to skip that slide. You can all read it if you want. So if you're interested, it's on GitHub. It's on the RCOS website. It's written in Go, which is Google's new language. According to Brock, if you know Go, Google will definitely hire you. So all the freshmen should join me to get hired at Google. Seriously. So that's it. Thanks to everyone here for listening to me. I'm Professor Morphy, Professor Goldschmidt, and Sam O'Sullivan. Are there any questions while the next guy sets up? Who's somewhere around? I don't know.
Yeah. Is it just for like web sort of stuff, or could it like be sort of an alternative to like GitHub or something?
Repeat what you said after an alternative.
Or could it be an alternative to GRP?
I have no idea what
I
GRP
think
is.
that would use generating native extensions.
Oh, so this is for deploying servers, right?
Okay, that's what it's for.
That's what it's for. It's for deploying images to servers. I guess you can deploy an image that builds your source code for you. Like it's totally possible. Barat might be doing that with ProtoML, but it's not
Okay. So it's not
a build system. It's purely for deployment.
So one of the common use cases that I have one server that runs multiple sites using Apache Beagles. How does this fit that?
Right? So you put so there's three ways to do this. One, you can do exactly what you have now with your server. You can build an Apache vhost, you can run it in a Docker container. Pretty trivial deployments. You can make updates, roll back, that sort of thing. There's slightly more advanced usage where in Apache vhost you essentially have multiple sites running, right? And with Docker what you can do is you can just run each of the multiple sites in their own Docker container. And they can't see each other, they get to pretend that they're root on their own file system, and then you can have one Docker image like Apache that sends traffic to each of them. And so that way they can't see the Apache process, there's better resource isolation, it's just like a BSD jail. Plus, it's trivial for you to be like, deploy in this site, oh I hate Amazon, deploy on Linode, oh I hate Linode, deploy in my own server cluster I built in my basement, oh it caught on fire, deploy in RPI Union servers, right? You can do that, really easy. So it's like that except it's automated, right? It doesn't change how things are, it doesn't change how your stuff is set up, it just makes it a little more secure, a little easier to deploy.
If you run a project this close, we talked about project or
Well, I know with Nginx you can do load balancing. I don't know what you can do with Apache with regards to load balancing, but even if you can't, you can run multiple processes inside a Docker container. So you could run Apache and the 12 processes or 15 processes or whatever you need inside it.
you need to handle the request.
Yeah, to handle the requests.
My concern here is that you can only have one process on the entire machine on that idea.
No, you can deploy as many Docker containers as you want to any machine, except resource limitations.
Now, that one machine though has one IP address with it. It's 480 and that IP address is a socket. You can't broadcast it.
So there's two things. One, how Docker works is while you can bind to specific ports on specific machines, like I do that for the orchestrator, or I really bind to port 900 for ease of discovery. With the secret manager, what port something bound to is a secret, it's handled by it. And so what you can do is you can just have Apache be deployed, and then you can deploy your each individual site generators or Django or whatever you want on each of the machines, and not care about what port they bind to, because they'll bind to port 80 in their machine, and then that port will get routed to another port on the outside of the machine, and you can just look up what that port is via the secret manager and handle it. I haven't written the integration with Apache yet, but it should be pretty trivial to do. I can do it in Nginx and do it in like 3 lines. Apache can't be that much worse. So it's a cool thing like that, right? It makes it harder to like have people break into your services and then discover everything inside of it, because you don't know the own details, so how can they know it without doing extensive work or busting your secret manager? Any other questions?